Imagine you're staring at a blank screen. You're completely stuck on this massive high-stakes project, just totally hitting a wall.
Oh, yeah, we have all been there. It is the worst feeling.
Right. But then suddenly, your digital notebook essentially taps you on the shoulder.
Like a literal notification.
Exactly. And it surfaces this half-baked, slightly chaotic thought that you jotted down at like 3 in the morning 3 years ago.
Wow.
And not only does it show you the note, but it explicitly points out how that old idea perfectly solves the exact bottleneck you're looking at right now.
That is wild.
And then it just goes ahead and drafts the solution in your exact tone of voice. So, welcome to the deep dive. Today, we are looking at a stack of sources from 2026, exploring the rapid evolution of the second brain.
Yeah, the mission today is really to unpack how large language models, or LLMs, are just completely revolutionizing personal knowledge management.
We're talking about moving from those static digital notebooks, where you just dump text and lose it forever, into an era where your notes act as an active, reasoning thought partner.
It's a huge leap. I mean, historically, we've always treated human memory like a leaky bucket, right? We just kind of accepted that information decays, and that's just the biological cost of doing business.
Yeah, you read a book and forget 90% of it a week later.
Exactly. And the original concept of the second brain, which was really popularized by productivity experts like Tiago Forte, it was designed to patch that leak through something called cognitive offloading.
Right, cognitive offloading, using an external system to hold the data so your brain doesn't have to.
Yes. The goal was to use this system to capture, organize, distill, and express your ideas. They called it the code framework. And the whole point was to free up your biological brain for actual creativity instead of just, rote memorization.
And most of us who follow this space are pretty familiar with the classic structural approaches to this, like Forte's PRA method.
Oh, right, the PRA method.
Organizing everything into projects, areas, resources, and archives.
Yeah.
But the thing is, maintaining that structure requires an immense amount of personal discipline.
It really does. You have to be meticulous.
You are the one manually filing everything into this pristine digital filing cabinet.
Yeah.
But what the 2026 landscape shows us is a massive paradigm shift.
It really is night and day.
Even Forte himself launched a cohort called the AI Second Brain. The philosophy is fundamentally changed. We aren't doing the manual filing anymore.
No, the system isn't just a dumb database anymore. It is essentially being treated as a new team member. It shifts from passive storage to active synthesis.
Okay, let's unpack this a bit for you listening, because the analogy I like to use. So the traditional second brain was like a perfectly organized, pristine filing cabinet, right?
A very quiet, very static cabinet.
Exactly. But this new AI version, it's like hiring a hyper-caffeinated intern who lives inside the cabinet, reads all your files, and constantly taps you on the shoulder to say, hey, did you notice this pattern?
That is exactly what it feels like.
But I do have to push back a little. Is it really reasoning, or is this just, a really fancy search function?
Well, that's the core of the transition. It actually is semantic reasoning. In a traditional system, you are forced to run a keyword search. So if you search your archives for the word vacation, you're only going to find notes that contain that exact string of letters.
Right, V-A-C-A-T-I-O-N.
Exactly. You won't find the note where you hastily wrote, trip to the mountains. The AI second brain completely leapfrogs that limitation by mapping meaning, not just letters.
Meaning over letters. Let me see if I can explain the mechanism behind this, because it's honestly fascinating. When you feed a note into an LLM, the model converts your text into a mathematical vector.
Yes, the vector embeddings.
Right. It essentially plots your ideas as coordinates in this massive multidimensional space. So the concept of a vacation and a trip to the mountains, they are plotted physically close to each other in that mathematical space.
Because they share the same conceptual DNA.
Exactly. So instead of a static filing cabinet where you have to know exactly which folder you put a paper in, it's more like a chemical reaction. You drop a new idea into the system, and it automatically binds to related ideas you had 3 years ago, because they just naturally attract each other.
That vector mapping is really the hidden engine driving all of this. And, it manifests for you, the user, in a few highly specific ways. First, there's automatic capture.
Which is huge.
It is. The system operates in the background now. It's transcribing your meetings, it's ingesting heavy PDF reports, processing your emails, and immediately plotting all of that into that multidimensional space.
No manual tagging required.
None. Then it uses knowledge graphs to visually and logically connect these completely disparate pieces of data.
Let's actually define that term for a second, because knowledge graph comes up constantly in the source material.
It does, yeah.
A knowledge graph is essentially a network of real-world entities. So objects, events, concepts, and the explicit relationships between them. If the vector mapping is the conceptual DNA, the knowledge graph is like the red string on a detective's evidence board.
I love that visual.
It explicitly defines how a meeting you had on Tuesday relates to a random PDF you read last year.
And that red string allows for something the researchers call graph RAG, or graph retrieval augmented generation.
Graph RAG. It's a bit of a mouthful.
It is a terrible acronym, but the 2025 and 2026 academic papers on LLMs as second brains point to this exact architecture as the reason we are finally seeing measurable, real-world improvements in complex problem solving.
Graph RAG basically acts as an accuracy filter. Right?
Exactly.
So instead of an AI just guessing an answer based on its broad, generalized internet training data, it first retrieves the exact verified facts from your specific personal knowledge graph.
It pulls your actual notes.
Right. And then it uses that highly specific data to generate its answer. It anchors the AI's reasoning entirely to your actual lived experience as notes.
And that anchoring is exactly why this is being deployed in incredibly high-stakes environments right now. The sources highlight pharmaceutical research as a prime example.
Oh, wow, pharma. That makes sense.
Yeah, because you have researchers managing tens of thousands of complex chemical interactions, clinical trial results, historical data. GraphRag allows the AI to reason across all that interdisciplinary data with pinpoint precision.
Because it's not just making things up.
Right, no hallucinations. But it's not just niche scientific fields either. Meta currently has 60,000 employees utilizing these exact concepts.
Let's put ourselves in the shoes of one of those 60,000 Meta employees just to understand the scale of this. You're an engineer dealing with thousands of bug reports, internal memos, coding frameworks.
It's a total mountain of data.
And a new bug pops up. Historically, you might spend 3 entire days hunting through old documentation just to see if a similar issue was resolved 2 years ago.
And you probably still wouldn't find it.
Right. But with an AI second brain, the moment that bug report hits your desk, the system's GraphRag architecture pulls up an internal memo from a completely different department written 18 months ago that contains the exact framework needed to patch the bug.
It's instant context.
The cognitive load of simply finding information is eliminated. You immediately shift your focus to high-level strategic implementation.
Lifting that burden across an entire enterprise fundamentally alters the speed of innovation. But, and this is what I find really fascinating, the research also emphasizes a highly personalized individual side to this.
It's not just corporate synergy.
No, not at all. Because the system maps your specific conceptual DNA, it adapts to your personal quirks. You can literally ask your second brain to tell you a joke based on your notes about productivity, and it will generate a punchline uniquely tailored to your own neurotic thoughts about scheduling.
Wait, really? It can be funny.
Yeah. It knows your sense of humor because it has mapped the vectors of your personal journal entries.
Okay, that level of mirroring does raise a complex question about our own agency, though. Here's where it gets really interesting for you, the listener. If the system excels at this kind of neuroscience-inspired interdisciplinary synthesis, if it's the one connecting the bug report to the old memo, or the punchline to my journal entry, are we still actually creating anything?
That is the big fear, right?
Yeah. If I'm just gathering the data and the machine's doing all the synthesis, my fear is that I'm being reduced from an architect to a bricklayer. Are we just feeding the machine ingredients and letting it bake the cake?
It's a very valid concern, but the structural requirement of the technology actually prevents that from happening.
How so?
The AI cannot generate original human context out of thin air. It only synthesizes the parameters you define. Think of it more like directing a documentary.
Okay, I'm with you.
You have thousands of hours of raw footage, which are your notes. The AI is a highly skilled video editor. But you, the director, you still have to determine the narrative arc. You have to tell the editor, hey, I want to explore the tension between these two specific themes.
Ah, I see.
If you just give the system generic direction, or if your raw footage lacks depth, the resulting output will be completely hollow.
Okay, so the magic really relies on the quality of the footage we shoot and how we actually set up the editing bay. Conceptually, I am sold on the power of this. But practically, if we look at the average person's digital life, it's a chaotic mess.
A total disaster, usually.
It's hundreds of unstructured Apple Notes, scattered bookmarks, half-read PDFs. If the AI is only as good as the context we feed it, how do you actually go about structuring your digital junk drawer so the AI can map it?
The sources outline a very clear, actionable methodology for building this out in the current 2026 landscape. You start by selecting a base platform that natively supports LLM integration.
So what are the top choices right now?
Obsidian and Notion are heavily utilized bases, obviously. But there are also specialized 2026 tools like Taskade, Personal AI, and various custom markdown agents.
What about people who hate reading long texts?
For those who process information better audibly, Notebook LM is fantastic. It generates interactive audio overviews of your text files.
Okay, but once you have your digital real estate picked out, you still have to organize the raw data before the AI can map it effectively, right? You can't just dump a gigabyte of unstructured text into a model and expect perfect synthesis.
No, that will just give you noise.
Huh.
You actually implement that classic PIRA structure we talked about: projects, areas, resources, archives, but you use the AI to supercharge the filing.
Oh, so you aren't manually dragging and dropping.
Exactly. You upload your messy notes and then use targeted prompts to have the model categorize, summarize, and establish the initial links between them for you.
And to keep that system alive, the next requirement is building zero-friction capture habits. The goal is to shrink the time between having an idea and getting it into your multidimensional space.
Right. If it takes 10 clicks, you won't do it.
Exactly. This means integrating quick capture apps on your smartwatch or your phone directly via API to your primary base. You're out walking the dog, you speak a thought into your wrist, and it's instantly transcribed, categorized, and embedded into your knowledge graph.
It is seamless. But getting the data in is really only half the battle. Tiago Forte actually identifies a massive hurdle here, which he calls the context bottleneck.
The context bottleneck, meaning what? Explain.
Meaning the AI is trapped by the limits of what it knows about you. If you want it to act as a genuine thought partner, you have to feed it your actual lived experiences, your failures, your raw opinions, your weird tangents.
So it's not just business articles.
No, it requires an iterative loop. You're constantly reviewing the outputs it gives you, and if the advice feels generic, you have to go back and actively add more personal context to the system. The richness of the synthesis is entirely capped by the vulnerability of your input.
Which opens up a completely terrifying door, if we are being honest.
It really does.
If I am feeding the system my raw, unfiltered thoughts and relying on it to synthesize my memory, well, wait, what happens when it gets it wrong?
Hallucinations.
Yeah, we know LLMs hallucinate. Am I going to find myself in a situation where the AI confidently connects two completely unrelated events in my life, feeds my own altered, incorrect notes back to me, and I just believe it because I've offloaded my memory to the machine?
It's a huge problem.
Am I going to start adopting the AI's hallucinations as my own memories?
That is legitimately one of the most severe risks identified in the 2025 and 2026 academic literature. Managing hallucinations in a system designed to hold your personal truth is a constant, exhausting requirement.
I can imagine.
But the research, specifically these major studies conducted by Microsoft in collaboration with Carnegie Mellon University, the MIT Media Lab, and a really prominent paper by Gerlich published in MDPI, they all warn that hallucinations are just the surface layer.
Just the surface. What's the deeper threat?
The deeper threat is the profound psychological impact of extreme cognitive offloading.
Okay, because earlier we framed offloading as a positive thing, reducing stress, freeing up the biological brain.
Yeah.
But the MDPI study points to a very clear tipping point, doesn't it?
It does. When you cross that tipping point and you begin relying entirely on the AI to execute all the semantic reasoning and connect all the dots for you, the studies demonstrate a measurable degradation in a user's own critical thinking skills.
A measurable degradation. That is intense.
It induces a phenomenon where your confidence in your personal judgment just plummets. When you are faced with a complex problem, you start second-guessing your biological brain's intuition because you've trained yourself to assume the AI's vector mapping is always inherently more thorough.
You know, we've seen this exact phenomenon before with spatial awareness.
Oh, with GPS.
Yes. Think about it. 20 years ago, people built intricate mental maps of their cities. We knew how to navigate. Then we completely outsourced our navigation to the GPS on our phones.
Because it was incredibly convenient.
Right. It eliminated the cognitive load of finding our way around. But the consequence is that today, we get lost in our own neighborhoods if our phone battery dies. We literally allowed the biological skill of spatial awareness to atrophy.
That is a perfect analogy for what is happening to our minds now.
What these CMU and MIT studies are warning us about is the risk of losing our intellectual spatial awareness. We're offshoring our reasoning to the point where we might forget how to form an original synthesized thought without typing a prompt first.
It is the danger of the tool becoming a crutch. And the literature compounds that psychological risk with serious architectural risks. Specifically, what researchers are calling the lethal trifecta in AI agents.
Let's break down that trifecta for the listener, because the implications here are structural. You have one, highly sensitive personal data. We were talking your journal entries, your therapy notes, your proprietary business
There's
strategies.
the most private things imaginable.
Right. Then two, you have a model capable of autonomous action and reasoning. And three, a direct connection to the internet.
And when you combine those three elements, the privacy vulnerabilities are monumental. If the system is breached, or, and this is more likely, if a provider quietly updates their terms of service to use your deeply personal knowledge graph to train their public models, the exposure is unprecedented.
That is a terrifying thought.
It is. And this also creates a massive equity gap in the landscape. The sources point out a rapidly growing divide between those who can afford highly secure, localized, premium AI tools and those who are forced to rely on less secure, open-source alternatives that might actively harvest their conceptual DNA to pay the bills.
So, to summarize, we're looking at a technology that can exponentially increase our ability to solve problems, but simultaneously threatens to erode our critical thinking, alter our memories, and expose our deepest private thoughts.
Still a lot to weigh.
How do we actually navigate that? Well, the source material proposes a very specific countermeasure to these threats, which they call the hybrid approach. If you were going to build an AI second brain, you have to maintain deliberate friction in the system.
Yes, deliberate friction is key. The first step in that hybrid approach is conducting rigorous, manual weekly reviews of your knowledge graph.
So no setting and forgetting.
Absolutely not. You don't just dump information in and blindly accept the synthesized outputs. You must manually review the semantic connections the AI is making, verify the underlying notes, and actively prune the network yourself.
Second, and this feels like the most vital safeguard against that GPS effect we just talked about, you must intentionally schedule brain-only work sessions.
I love this concept.
Yeah, I mean, stepping completely away from the AI,
Yeah.
you sit with a blank physical notebook or just your raw, disconnected digital text, and you force your biological brain to do the heavy lifting of synthesis.
Right, you do it manually.
It's exactly like going for a run even though you own a car. You don't need to run to get to the grocery store. The car's faster and way more efficient, but you do it to keep your cardiovascular system from collapsing. You have to exercise your biological reasoning muscle so it doesn't atrophy.
That is such a crucial practice. And the third pillar of the hybrid approach is the active cultivation of metacognition.
Metacognition. Thinking about how you think.
Exactly. In the context of an AI second brain, it means remaining deeply critically aware of your interactions with the model. Why are you asking the AI to connect these specific dots? How are you evaluating its response? Are you accepting its synthesis because it's genuinely brilliant, or simply because it's formatted convincingly?
You're the director. The AI is the co-pilot.
It must never become an autopilot.
Well said. When we maintain that metacognition and we keep our hands firmly on the steering wheel, an AI second brain does something truly remarkable. By handling the rote memorization, the endless sorting, and the structural heavy lifting of vector mapping, it creates a void.
A very necessary void.
And we get to fill that void with the things an LLM simply cannot do. Dreaming, empathizing, and innovating. It literally gives us the cognitive space to be more deeply human.
It really does, if used correctly.
But as we wrap up this deep dive, I want to leave you, the listener, with one final, slightly provocative thought to mull over on your own. We've talked extensively today about how this system acts as a mirror, mapping your conceptual DNA.
Right.
So imagine it is 10 years from now. Your AI second brain has ingested a decade of your deepest thoughts, your frantic 3 a.m. epiphanies, your strategic frameworks, and your unique sense of humor.
Everything that makes you, you.
It flawlessly mimics your writing style and your reasoning. It knows your context perfectly. If an algorithm can eventually synthesize your ideas, connect your disparate thoughts, and express you faster, and perhaps even more eloquently than you can, what happens to your first brain's sense of identity?
Wow.
Definitely something to think about during your next brain-only session. Thanks for joining us on this deep dive. We'll catch you next time.